Okay, so last time we looked at all of the graphical analysis of our basic motion, your distance, your displacement, your velocity, and your acceleration. So this time we're going to look at the mathematical side of it. So when you're looking at the term kinematics, you're really talking about you have to be able to describe motion graphically, mathematically, and conceptually. So knowing what they are, what they look like on a graph, and finally with equations. So we're going to look at the equations today for you for this unit. Okay, so the first thing that we're going to do, this is again just what I just said about kinematics. It's a way to describe your motion. So mathematically, pictorially, graphically. Okay, the pictorially goes along with that idea with the graphs. Okay, so looking at pictures, the AP problems like to put pictures on there that you have to break down and describe. So here are your main units for you for this, or your main variables. Okay, you're going to want to make sure you memorize this. So time is always represented by lowercase letter t, always measured in seconds. A is your acceleration, always measured in meters per second squared. X or Y is going to be your displacement, always measured in meters. V naught is going to be your initial velocity. That naught means like original. So some people say V0, VO, V naught, they all mean the same thing. Okay, it's always your initial velocity. Velocity is always measured in meters per second. Your final velocity, your AP equation sheet likes to put just V. When they're putting just a single letter for velocity, they're meaning your final velocity. I know it gets weird with final versus just regular velocity. So they use V. I like to use VF. Just so that way you don't get confused as you're writing down your variables. If you just put V, are you talking initial? Did you just forget to put initial? So even though your AP College Board, they put just V, they will accept VF. Okay, so it's not like you're going to lose points if you use VF instead of just V. So I recommend using VF just to, again, to help yourself keep organized. Velocity, again, even though it's final velocity, still measured in meters per second, and then your acceleration is in meters per second squared, and you'll sometimes see your acceleration is also represented by the letter G, talking about gravity. Okay, so you'll sometimes see it in two different, either AG or G, okay, that you're looking at it. So your three kinematic equations, these are on your equation sheet. I recommend memorizing them because you're going to use them all the time. So the quicker you are at memorizing these equations, the faster the homework's going to be. Remember, your AP test is timed, and I can tell you year after year people run out of time. So the more equations you can memorize that you're going to use over and over again, the less time you're going to spend using, like, searching that formula sheet for an equation. Okay, just memorize them. These, you're going to use them all the time. Okay, so in all of these cases, though, there's one big thing. In each situation that you use the equation, the acceleration has to be constant. So if your acceleration goes from 4 meters per second squared to 8 meters per second squared, you have to use the 4 meters per second squared for one time frame, one equation, and then you'll have to do it another time frame with the 8 meters per second squared. So all of these A's are just A. If you have multiple accelerations, you have to use multiple amigos. Even if it's the same amigo over and over and over again, you have to use them. Okay, so that's the big thing. So the first one is VF equals V naught plus AT. Then you have X equals X naught plus V naught T plus 1/2 AT squared. Only the T is squared on that equation. And then finally, V squared equals V naught squared plus 2A delta X. Okay, again, you have that X final minus X naught. That's the same thing as delta X. Okay, sometimes you'll see it as delta X. Sometimes you'll see it as X minus X initial. Okay, it's up to you. Okay, so here's where these three equations come from. Your first one, that VF equals V naught plus AT, is just your acceleration equation rearranged. So you've already seen this equation for acceleration. Acceleration, delta V over delta T. Delta, again, final minus initial, so you break it down, final minus initial, over your time. Okay, and then rearrange it, and you end up getting this equation for VF equals V naught plus AT. So it's just your acceleration equation. You'll notice that a lot of times they drop the delta on time because normally you're always referring to time 0 or your time naught as being 0. So when we're starting with timing things, you normally start 0 seconds as your initial, 5 seconds would be the second one, okay? It's just how they do it. Every time you run a race, they don't start you at different times. Everyone starts at time 0. Okay, so that's why a lot of times you can just drop it, and then that T, again, would just be like your final time. So how long did it take you to race? Okay, so normally it's always 0. There are a few problems sometimes where they'll trick you. Will they say starting at 2 seconds? Okay, so just make sure you're aware of it. But most of the time it's just time 0 is 0. Okay, so here's again looking at your graph. Okay, this is from last time. So you had this graph from last time. Okay, so we're kind of reversing this a little bit, reviewing from last time. You had a velocity versus time graph. If you wanted to figure out how far you went during a time frame, you would sit there and figure out your area under the line. Okay, those of you that are in calculus, if you want to use the integral, go right ahead. Okay, that is completely fine with me. Not in calculus, find your area. Okay, break it down into 2 pieces. You have a triangle and a rectangle. Find your area under each segment. If you just do the area that goes to the 1.5 right here, you're just finding the area under how fast, like under the 1.5 seconds. But you're not including the fact that you're not traveling, like you're above the 0. So you have to do the entire part from the line all the way to the x-axis, the entire piece, okay, as you're looking at it. So this is to refresh your memory from last time, and I'm going to show you why this matters. If you look at your area here for the square, you're taking velocity times time. If you're taking your area under for the triangle, again, you're doing 1/2 velocity times time. And if you look at that, we can take that and find our next amigo. So the second amigo, if you look at it, it is x equals x naught. This x naught, again, normally 0, but if you're starting like a race and one person, you're giving them like a head start. You start at the same time, but one person starts 5 meters like ahead of the other one. That's where you'd want to include this x naught, is if you're starting at different distances. So you have that VOT, okay? That VOT was that base times height that you just did on the previous example, on that graph. Base times height, velocity times time. Okay, that second part, if you break this down, this is acceleration times time times time. Okay, so t squared, t times t. Acceleration times time becomes change in velocity. So if you look at that, that's finding the area underneath the underneath the triangle. So the graphical stuff that we did last time where you were finding your displacement is the same thing as using the equation. Okay, this equation is derived from that graph. Okay, if you're moving at a constant velocity, then it would just be a rectangle, so it would just be base times height. Okay, so you wouldn't even have to use the second part of the equation. Okay, so again, looking at how these two things go hand in hand with kinematics, your graph leads to your equations. Okay, and vice versa. Okay, again, like it says here, x naught's normally 0. If not, if you're starting ahead, if you've ever raced a little kid, normally the little kid, you give them a head start. Okay, let them win. Okay, until they reach a certain age, and then that goes out the window. Okay, then here's the third amigo. Okay, the third amigo is kind of on its own. The derivation of it's long, so I'm not going to show that to you. But here's an example of it. Okay, if you're driving a car through town at 12 meters per second, suddenly rolls off, a ball rolls out in front of your car, you apply the brakes and begin to decelerate at 3.5 meters per second. Again, you can use 3.5 meters per second or meters per second squared. Okay, as you go through that problem. Okay, so one of the problems that you have is not knowing which equation to use. So you have your first, each one is missing some variable. So if you're using the first amigo, you're not worried about that distance factor. If you're using the second equation, you're not worried about the final velocity. If you're using the third equation, you're not worried about time. So each one is missing something. However, all of them you have to have an acceleration. So if you don't have an acceleration, find that first, or that's probably what you're solving for. And then all of them have an initial velocity in them. Okay, So those are like two important things that you normally need to have. All right, so we used X's for everything. You can use your kinematic equations or the amigos also for the y direction. When you're using the y direction, the only things that change are now your variables get a y in addition to the letters, okay? So instead of it just being your final velocity, it's final velocity in the y. Instead of it being just initial velocity, it's initial velocity in the y. That's it. And then when you're looking in the y direction, your acceleration is going to be gravity. So instead of using A, we just put a generic G because everything in the y direction is under the influence of gravity, okay? Even if you're outside of Earth, you're still under the influence of somebody's gravity, okay, for all of our problems. We're never going to do a problem where there's no gravity at all. Okay, so you don't have to memorize these other equations. Just know that instead of X, it can be Y. Okay, that's it. All right, so I want you to try this problem. So you have a car is approaching at 45 meters per second to the east and starts to approach a stoplight, and that turns red. The car sees the red light and slows to a stop in 1.4 seconds. The light then turns green and the car accelerates at a rate of 4.2 meters per second squared and reaches a speed of 54 meters per second. How far did the car travel during both segments? So I'm looking for how far, so I'm looking for a distance. Okay, so as you're working this problem, the first thing I want you to do, and this is for all your problems that you ever work in physics, is you're going to start by writing down your givens. What do they tell you? Okay, you have two different segments in this, so you want to break it up into two pieces for it. You have while the car is approaching the stop, and then you have after it turns green and it starts to go again. So that means you're going to have two sets of initial velocities, two sets of final velocities, two sets of accelerations, two sets of time, two sets of displacements, and then you're going to add the two together. So during the first section, you're going to, again, write a list first of all of your givens. Okay, I want to see this. College Board wants to see this. It's all to your benefit, because if you mislabel a given and then you work the problem out correctly just using your givens wrong, College Board's going to follow your process, and they're only going to take off a point or two for getting the wrong answer, but they're still going to give you the rest of the points on a free response problem for using the right process. Okay, and that's the same way I grade. Okay, partial credit is your friend. So if you just put the wrong answer down and I can't see how you got there, I can't give you any points for that. Okay, College Board literally will give you points if you use the right equation. Okay, same thing I do. So show all of your work. Show it neatly. Show all of your work. So the first thing they tell you is you have an initial velocity of 45 meters per second to the east. So you would write that as V naught. So V naught, if you want to label it to keep the times different, you can label it as segment 1. So you could do V naught 1 is 45. You can make it in two different tables, whatever you want. Okay, it says that it starts to approach a stoplight that turns red. The car sees the red light and slows to a stop. So that means you're stopped. So your final velocity for segment 1 is 0. And then it says your time is 1.4 seconds. Okay, so that's what you know for the first segment. You know V naught, VF, and your time. Then for segment 2, it tells you that the light turns green and the car accelerates, okay? But the car was at rest. So this means now for segment 2, you're starting from rest, so your initial velocity is now going to be 0. So V naught 2 would be 0. It accelerates at a rate of 4.2 meters per second squared, so that's your acceleration. And it reaches a speed of 54 meters per second. So that's going to be your final velocity. Okay, and again, you're looking for delta x. So go ahead and take a minute, try it, use your different amigos. I will tell you for the first one, you have to use 2 amigos, because you don't know your acceleration and you don't know your displacement. Acceleration is in every single equation. So if you wanted to try and use your delta x equation, you can't. Because what are you going to do with 2 unknowns in an equation? So take a minute, work on that. So I would use the first amigo to find your acceleration first for the first segment. Pay attention to the positives and negatives. So what you have, there's your givens. Okay, sorry, my format is a little weird. So first thing again, during segment 1, you're going to use that first amigo, VF equals V naught plus AT. I'm going to solve it for acceleration first. Again, show every step, because if you rearrange this equation somehow, you put, misplace the T or something like that, if they can still follow your process, you might lose a point or two, but that's it. Show every step. If you do not show your work, I will not give you credit. Do not challenge me on this. Okay, so your acceleration, final velocity minus initial velocity over time, plug it in. 0 minus 45 divided by 1.4 gives you negative 32.14 meters per second squared. For all the problems you work, physics is not real specific on decimal places, so I recommend just rounding everything to the hundredths place. Just to be consistent, round everything to the hundredths. Now when you do your online homework, don't round. Okay, within that program. Okay, that's a whole nother issue that I'll talk about later. Then once you know your acceleration, then you can use the second amigo to find your displacement. So you're using your initial velocity of 45 times your time plus 1/2 times your acceleration. Your acceleration is negative, so you must include that in there. If you think about it, again, you're slowing down. So that means if your velocity is positive, your acceleration has to be negative. Those signs always have to be opposite if you're slowing down. And then your time is squared, so you get 31.5 meters. So that's for segment 1. That's how far you traveled. Then for segment 2, look back at your givens that you have. Okay, again, you're still looking for x. So now I'm going to use the third amigo. So x equals, so VF squared equals V naught squared plus 2a delta x. Again, solve it for x. Show your work. Okay, so then x is going to be 54 squared minus 0 squared over 2 times 4.2. Be careful with your parentheses to make sure you get the right answer. If you type in 54 squared divided by 2 times 4.2, you will get the wrong answer. Unless you use parentheses, you will get 6,123 instead. Sorry, my battery's running low, but I'm almost done, so it's okay. And then add your two distances together.